name because I am a professor and I do teach chemistry. So for those of you all that are on the struggle bus and you need additional help, by all means, make sure that you guys get it. I give away free tutoring Monday through Thursday, 12 noon Eastern Standard Time for General Chemistry 1 and General Chemistry 2. I try to go between both of you all, okay, because I know oftentimes it is very difficult to get the help that you need from your professors. And so this is why I am doing what I do to ensure that you guys are able to get the help that you need as well. Okay. So let's go ahead and get started with this. But before we start, make sure you have your pens, your paper, of course, your calculator, because, I'm going to type in the numbers live so that you guys can see me do the calculations with you. And make sure you guys are staying hydrated. I've got water, because I do so much talking. So if you all need additional help within these problems, you'll know what to do as well, okay? So today's lesson deals with molality and colligative properties, okay? So in case you're wondering, what is colligative properties? Colligative properties are basically those things that depend on the concentrations of solute particles, okay? And the solvent. So when you think about a solute versus a solvent, you're actually looking at the two. The units are not always the same either. Okay, so when you think about molarity is moles per liter, but when you think about molality are moles per kilograms. Okay, so the moles of the solute divided by the kilograms of the solvent. So let me go ahead and put that up here so you all can see it. Okay, so again, when I say molarity, okay, if any problem dealt with molarity, it's the concentration of the solution. Molarity is moles per liter. Okay, moles per liter. But when I say molality, and let me put that in a different color so you all can see that, because there is a difference. Molality, that deals with the moles of the solute, okay, versus the kilograms of the solvent, okay? So usually the solvent is the liquid, okay? So when we go through these problems, I'm going to be weighing heavily on molality though, okay? Molality. And I will put the formulas back on the screen so that you guys can have access to them as well, okay? And thank you guys so much for I don't know why they still have the little bunny rabbits, because we're done with Easter. So I don't know why they don't just put the hearts back up there. I like the flowers though. The flowers are pretty. Mm-hmm. So there are several formulas that we're going to also use throughout this particular lesson that I give today. And one of the formulas is this one right here, okay? This is delta T of F, which is the change in freezing point. And that's equal to the constant for the solvent, okay? The K of F times molality, okay? So that is the formula that we're going to use. And again, let me identify each of them so that when you all hear me talk about it, you'll know what I'm referring to. So again, delta T is the change in the freezing point. Okay, the change in the freezing point, and the K of F, that is equal to the constant that differs for each of the solvents, okay? And it is a negative number. So the K of F, and I'm going to actually pull this down so you all can see it, but it is a constant for the given solvent. And it is negative, okay? It is negative. And then the last one, the M, that is for molality, okay? So the M, and I'll put that here, the M is for molality. And again, the molality is equal to the moles of the solute, okay? The moles of the solute divided by the kilograms of the solvent, okay? So that is the difference between the two right there. Now, also, let me pull this down so you all can see what I'm talking about. As you all can see here, these are the various solvents that you all see, okay? These are the various solvents here. And let me zoom in a little bit so you all can see that, okay? So these are the solvents like acetic acid, camphor, ether, phenol. So right here, phenol. But what you guys can see here, this K of F, this particular column, these signs are negative, okay? Those numbers are negative. So when you think about how to calculate these problems, you got to use a chart. And your teachers are not going to have you memorize them unless they're on some power trip. That's the only way I can see them doing that, okay? So for this particular part right here, if we look at this problem, okay, we're going to read through what we were given so we will know how to solve this problem, okay? So they're asking you to find the freezing point of a solution of 210.0 grams of glycerol, and this is the formula for glycerol, that's dissolved in 350 grams of water. So you already know that the 350, of course, is the solvent, okay? That's usually your liquid right there, so that is your solvent. And of course, the 210.0 grams, that is your solute, okay? Now, what you need to also keep in mind is that when you're looking at your problems, okay, they're going to give you different things that you need in order to solve the problem. So right here, because they're asking for the freezing point, you're probably wondering, well, what do we have to do in order to solve this problem? So let me go through this with you all right now so you will know exactly what to do, okay? So that you'll know what to do. So for this particular problem, one of the first things that we're going to have to do is convert the 350 grams to a kilogram, okay? So in this problem of what they were giving us, we'll need to convert that number. So let me also insert a separate page because we're going to need all the space we can get, okay? So right here, and I'm going to write down the numbers too. All right, so right here, writing down what was given. So they gave us 210.0 grams of glycerol, okay? Which is the solute. And I'm gonna put that in parentheses so you will know that. That is a solute right there. Let me zoom out a little bit so y'all can see that, okay? That is a solute. They also gave us 350 with the decimal on the end grams of water. Now, again, that is your solvent. Now, what I'm going to do also, I'm going to go back up here to the chart, and I'm going to go ahead and take the number here, that negative 1.86 right here. Let me go ahead and highlight that so you all can see that. I'm going to take this number here because this is the number for our solvent, okay, that we're going to need right here, okay, up here in this chart. We're going to take that negative 1.86 degrees Celsius per molality, okay? So we're going to use that number also. So negative 1.86 degrees Celsius per molality. That is your K of F, okay? That is your K of F. So now, how do we solve this problem? What do we need to do? Well, we're going to first convert the 350 point with the decimal on the end water, okay, to a kilogram. All you have to do is move your decimal back 3 places to the left. 1, 2, 3. So you end up with 0.350 kilograms of water, okay, of your solvent. That's for your water, okay? Now, the next thing you're going to have to do, you're going to take that 210, okay, that 210.0 grams of glycerol, and you're going to have to convert that to a mole. Because remember, when you're dealing with molality, you have to put your answer in moles. So we're going to have to convert the 210 grams of glycerol to a mole. Now, if you don't remember, okay, you must have the molar mass of the glycerol, okay? You got to find the molar mass of your glycerol. Now, remember, this is the formula that they gave us, all right here. So you'd have to use your periodic table to find out the molar mass for all of those. So you would add up all of your H's, all of your O's, all of your carbons. So your carbons, hydrogens, and oxygens in this formula for glycerol. Now, to save you time, I've already done that. So that's the other number that they have given us in this, that I'm going to provide you with, rather, for this problem. Okay, so the molar mass, let me put that here, for glycerol, okay, is 92.11 grams per mole, okay? So that's the number that we're going to use for this problem. So I'm going to take the 210.0 grams and convert that to a mole. So watch me as I do this next step. 210.0 grams of glycerol times, on the very top, I'm going to put 1 mole of glycerol. Rather than writing out that whole formula, you can just write the name of the formula. And on the very bottom, 92.11 grams of the glycerol. All you're going to do now is cancel out your grams, the unit that is, okay, because we don't need those units anymore. And we're going to plug this into our calculator. So I'm going to go ahead and do that now. That's 210.0 divided by 92.11. And we need 4 of those numbers. So we're going to get 2.279, which rounds off to 2.280. 2.280 moles of glycerol. Okay. Now, what are you going to have to do next? Well, we're going to have to take that number and use that into our molality calculation. Okay. So if you remember, molality, okay, let me say that again. Molality is equal to the moles of the solute, okay, divided by your kilograms of the solvent. Now, we can do this one of 2 ways. Because they're asking me, okay, to find, right back up here, to find the freezing point, and this is our formula right here, I can actually plug in the numbers right here in this formula. So I'm going to take this formula that I wrote, delta TF equals K of F times the molality. I'm going to take that formula and I'm going to show you how we're going to do this so we can work it out in one swoop, okay, rather than doing multiple steps. And also, you know, because I want to make sure that you all can see this, I'm going to put the problem side by side so you all can see the steps that I'm actually going through to do this problem, okay? So right here, I'm going to use, and I'm going to put that right here in this space right here below the yellow line, okay? So I'm going to put the formula here, delta T of F equals K of F times molality. So my freezing point that we're looking for, it's going to be negative 1.86 degrees Celsius / molality unit times. Now right here, I'm going to put in the 2.280 over 0.350 kilograms. Now remember, these units right here, guys, that you see right here, okay, I'm going to zoom in a little so you all can see that. I'm going to put the M there for molality because those units are going to cancel out anyway. Moles is on top, kilograms is on the very bottom, and so that it allows me to just simply cancel out my molality unit here, I'm going to plug that into my calculator now, okay? So I'm going to say negative 1.86 times 2.280 divided by 0.350. And we only need 3 of those numbers. So our answer here for delta TF is negative 12.1, okay? So our answer here for delta T of F is equal to negative 12.1 degrees Celsius. And that is our answer for that particular problem. Okay? So now, any questions about that particular problem? Okay? Any questions? All right, now we're going to move on to the next problem, okay? So for this next one that we have, I'm going to zoom back out, okay, just a little bit right here so we can see the next problem. So let me go ahead and increase that one so we can get to this next part of the problem. And I'm going to do this one right here, okay? We're going to do number one. Oops, you can't see that. Let me zoom out a little bit. We're going to do number one right here. Oh, good, Jaden. What was your grade in? What test did you have, Jaden? What was the topic? And 87 is amazing. That is fantastic. You know, I love hearing these good stories, these good success stories, especially when we're talking about chemistry, because we know how challenging chemistry can be. Okay. So while we're waiting for Jaden to tell me the topic that they had their test on, okay, let's go to number one. On molarity. Okay, got you. So look, you can help us out with this problem. Okay, I'm gonna depend on you. All right. So for this next one, let's look at number one. Okay, we're not looking at number two. We're gonna look at number one. It says determine the freezing point of a solution of 60.0 grams of glucose dissolved in 80 grams of water. Okay, so here's what we're going to do. First thing is they gave us 60.0 grams, okay, of glucose, and that is your solute, okay? Your solute is typically your solid form of your compounds. So if you're dealing with glucose and water, we know that the glucose is the solid and the water is the solvent, okay? So I'm going to take the 60.0 grams of glucose times. I'm going to put 1 mole, okay, of glucose on the very top. And on the very bottom, I'm going to put the weight for glucose on the very top. Now, again, this is a lesson for those of you all that forgot on how to calculate the molar mass for your products, okay? Let's do a quick lesson on that. Again, your teachers aren't going to take the time to do that. But you look at your periodic table and you know for carbon, you have 6 carbons. So you're going to say 6 times 12.01. And you get 72.06, okay? Then you're going to do the same thing for hydrogen. And you got 12 hydrogens times 1.008, okay? And then you've got your oxygens, and you've got 6 of those. And I'm going to make that 12.10, okay? And I'm going to actually start this part over. I'll rewrite this over so that I can have some space to write everything out. Because this is important that you guys know how to do these types of examples. Because some of you all may have forgotten how to calculate the molar mass, okay? For your oxygen, that's 6 of them times 16.00, okay? And all you're going to do now is add all those up, okay? The 96.00 plus the 12.10 plus your 72.06, and you get 180.16 grams per mole, okay? So you've got to find the molar mass of your solute. So anytime you're doing these problems, guys, you got to make sure that you're able to find the molar mass of your solute. So in this particular case, they gave us 60.0 grams of glucose right there for number one. 60.0 grams, okay? So again, let me zoom out so y'all can see the whole screen a little bit, okay? So right here, I'm gonna put it in a different color so you all can see what I'm doing. 60.0 grams of glucose times, on the very top, 1 mole of glucose, and on the very bottom, 180.16 grams of glucose, okay? Cancel out your grams because you don't need the unit of grams anymore. And all you need to do now is divide those two numbers, okay? So you're going to say 60.0 divided by 180.16. And you only need 3 of those numbers. So I'm going to write 0.333 moles of glucose. All right, we need that number because we're also going to have to do what? We're going to convert the grams of water, okay? So we had 80 grams of water. And let's make sure we get the correct sig figs. That was 80.0 grams of water that we need to convert to a kilogram, okay? All we're going to do is move our decimal back 3 places to the left. 1, 2, 3. So that becomes 0.080, and we need another 0 because we need to have 3 significant digits, kilograms of our solvent, okay? Now, for this last step, we need to go back to our chart because we need to look at the chart. Well, actually, we remember the number from before for water, okay? Because remember, we have to use the value for our freezing point for water. Going back up here, that negative 1.86, okay? So what we're going to do is plug that in right here. Whoops. Okay. And we're going to, let me insert another page. Hold on, y'all. It'll do that. Nope. I'm going to take these numbers. I'm going to have to squeeze everything up here just to prevent from making a mess, okay? I'm going to take my formula. The delta T of F equals negative 1.86 degrees Celsius per molality times. And remember, I'm going to take these two numbers over here. The moles that I just calculated, the 0.333 moles goes on the very top, okay? So 0.333 divided by 0.0800. And I'm just going to put that little funny M for molality, okay? And all I'm going to do now is get rid of my units here for molality, because we don't need those anymore, okay? Cross those out, the M's cross out, okay? And we're left with degrees Celsius because we were trying to find the delta T of F. So all you're going to do now is take that negative 1.86 times 0.333 divided by 0.0800, and that gives us negative 7.74 degrees Celsius, okay? 7.74 degrees Celsius. And if you go back up here to the answer, you'll see there it is right there, negative 7.74 degrees Celsius, okay? Now, on the next problem, okay, that we're going to do, number 2, we've got to do the same thing as we've done before, okay? So I'm going to let you guys kind of help me out along the way, okay? So for number 2, matter of fact, let me just copy this problem here, and I'm going to put it on a separate page. Okay. So let me insert a separate page. Whoops, well, It did it like that. Okay, there we go. Let me move that up. Okay, so we're on number 2 now, okay? And I'm going to hide part of number 1 so that way we can just focus on number 2. So I'm going to zoom in so y'all can see the problem. Again, the formula is delta T of F equals K of F times molality. What they gave us in the problem, okay, was the 645 grams of urea that we have to first convert to a mole, okay? We got to first convert that to a mole. And this is for your solute, okay? That goes on the very top. They also gave us 980 point with the decimal grams of water that we have to convert to kilograms. This is your solvent, okay? And you know molality is equal to the moles over your solvent, okay? Your kilograms of your solvent, okay? So what we got to do first, we got to calculate the molar mass for the urea, okay? That's the first thing we need to do. And to save on time, we're going to make this a Googleable thing, okay? So molar mass for urea, just to save on time, 60.06 grams, okay? 60.06 grams. So we did need that, okay? So I'm gonna put this over here also under part of what we need. The molar mass for urea is 60.06 grams per mole. And of course, we're still talking about water. So the K of F is equal to negative 1.86 degrees Celsius per molality. All right, so let's go ahead and solve this problem, okay? So what you're gonna have to do is plug in those numbers. But first, you've got to convert the grams of a solute to a mole, okay? So the grams of that solute, again, if we go back, was 645 grams, okay? So that's 645 grams of urea times 1 mole, okay, of urea over the molar mass of urea. Okay, again, we're going to plug this into our calculator right here. There we go, okay? We're going to take the 645 and divide that by 60.06, and we get 10.7, okay? 10.7 moles of urea. Now, we're going to also take our water, that solvent, okay, that they gave us. This number right here, okay? We're going to have to convert that 980 grams of water to a kilogram. And all we need to do, guys, is just move the decimal 3 places back to the left. So I'm going to show you all right here on the side that 980, we're going to move 3 places to the left. I put it in blue over here so you all can see that, okay? So here it is right here. That's 1, 2, and 3. So we end up with 0.980 kilograms, okay? That's the solvent that goes on the very bottom. So for step 2, convert the grams to kilograms of your solvent. And we already did that. So now let's go to our formula. Delta T of F is equal to the negative 1.86 degrees Celsius per molality. Thank you, Dr. AJ. Appreciate that. Okay. And then we're going to multiply that times, remember the moles of your solute goes on top, 10.7 divided by the solvent, 0.980. And I'm going to put that funny shaped in because those are the units for molality. And we're going to cross out our m's because we don't need that anymore. And let's plug that in, okay? So we got 1.86, negative 1.86 times 10.7. Divide that by 0.980, and you get 20.3. Negative 20.3 degrees Celsius. Oh, thank you. Thank you. Thank you. Send them my way. Send them my way, Dr. AJ. Send them my way. So if we go back up here to our final answer, now they got negative 20.4, but I got negative 20.3. The numbers are still tomato. They're still within reason. Okay? So that's how you do those types of problems. Any questions? Any further questions? Okay. So if there aren't any further questions, I may be able to do one more. I might do one more type of example like this. Let's see. Let me find one for you guys. Let me find a good one. Let's see here. I'll give me a second. I'm gonna pull up one for you guys. Oh, I got one. This one though deals with molality, and this is where I probably should have started the lesson at anyway, on molality. Matter of fact, let me find it. Yep, this one. So you know how we kept talking about molality, right? Well, here it is right here. Now, what do I have? Whoops. Okay. Let me just do a different screen. That way it'll make it a little bit easier. Okay. So I put this problem right here for you all, okay? And this deals with molality right here. Okay? So with molality, you only need to do what? You've got to find your well, let me start off here. Let me crop this page out so that we're only focusing on problem 12.60, okay? So let me go ahead and crop this one out to make it a little bit easier, okay? Right here. All right, so we're gonna look at 12.60, letter A. All right, so if we're calculating the molality, remember molality is equal to the moles of your solute, okay, divided by the kilograms of your solvent. So if you look at your problem, they're telling you that you have 65.0 grams of glucose, okay? So you know that that is your solute. Let's identify that. That is your solute right there. They also gave you 0.112 kilograms of water. So that color isn't coming up too well, so let me use a different color. 0.112 kilograms of water. That is your solvent. Okay? First thing you got to do for this problem is to take the 65.0 grams of glucose, okay, and convert that to a mole. And remember, we used the number before, the 180, okay? If you recall, we already found the grams of the molar mass of glucose, which is 180, okay? So we're going to put that on the very bottom, and we're going to cancel out our like terms. Get rid of your grams of glucose, and all you're going to do is say We're talking about molality, Shohag, molality. Molarity deals with moles per liter, but molality deals with moles per kilogram. Yes, moles per kilogram. So you're going to take the 65.0 divided by 180, and you get 0.361 moles, okay? 0.361 moles. Now, the kilograms is already there. They already made this easy for you by placing your kilograms in kilograms. So you don't have to do what? You don't have to convert, okay? So they've already done that for you. So now what are we going to do? We're going to take those numbers and just plug them in up top, okay? So I'm going to plug these numbers here. The moles that we just calculated was 0.361. And on the very bottom, the kilograms, 0.112, okay? Kilograms. So moles, kilograms. Well, those two units are going to form the little funny shaped M for molality. So all I'm going to do now is put in 0.361 divided by 0.112, and I get 3.22 and the funny shaped M for molality. So we just calculated the molality of this solution. Okay, we just calculated the molality of this solution. All right, Shohag asks, is the solvent always a liquid? Yes, 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 yes. And also too, when it comes to molality problems, you can easily identify the difference between the two because yes, it is typically a liquid, okay? And the number that they give you will always be or should be in kilograms. And if they don't give it to you in kilograms, you have to convert it and put it in kilograms. All right. And we're going to do letter B, okay? We're going to do letter B. We're going to wrap this up with letter B. And this is for sucrose, okay? Two different sugars, okay? One is glucose and the other one is sucrose. Let me grab me some water. Okay. So now we're on letter B, okay? So I'm going to erase this one right here because we're now on letter B, okay? All right. And I'm going to erase this so we don't have to focus on those numbers either. So for letter B, you were given 0.320 moles of sucrose. Again, that is your solute, okay? And your solvent is the water. 1.50 kilograms of water. First thing you need to do is take the 0.320 moles and divide that by the kilograms. So you know what we did here in this problem? We already put the number of moles in moles. So you didn't even have to do an extra step. But in the first problem, they gave you grams and you had to do an extra step by simply converting that number. So the good thing about this particular problem is, but you know, most teachers won't do this though. They won't make it easier for you. They'll give you problems like letter A to give you extra steps. But what they will provide, at least I would hope so, is the molar mass so that you can convert the 65 grams of glucose to the moles. So in part B, we made it easy for you. We got the moles and we got the kilograms. So just plug this in, 0.320, and divide that by 1.50, and you get 0.213. 0.213, and that funny shaped M for molality. Okay. Any questions? Any more questions from anybody about this particular topic? Okay. B Moose said, how do you know the right significant numbers? That's a very good question. How do you know? Because here's the deal right here. In the given problem, they initially gave you 3 significant digits here, and they also gave you 3 significant digits there. So anytime you are multiplying or dividing, you always get the least amount of the numbers that you are actually using. So in this particular case, since they both had 3 significant digits, that means I'm going to stop my numbers at the first 3. So if we look at this number here, I only need the first 3 of those, 2, 1, and 3. Now, had the 3 over here been a 5, then this 3 would have rounded off to a 4. So it would have been 0.214 if that were the case. How do you find the molar mass? Again, the molar mass is found by taking each of those formulas. So let me just do this one right here. Okay, so you can see what I'm talking about. So over here, okay, I've got carbon 12. Let me just write that over so y'all can see it. Oops. To find the molar mass. Oh, thank you, Diana. I appreciate that. To find your molar mass, again, all you have to do, if I were doing, let's say, C12, H22, O11, okay, oxygen 11. What you would have to do, I'm going to zoom in so you can see that a little bit better, okay, right there. All you have to do, okay, is take each of these elements apart, carbon, hydrogen, and oxygen. You've got 12 carbons, you've got 22 hydrogens, and 11 oxygens. You're going to multiply each of them by their respective numbers from the periodic table in terms of their weights, their molar mass. And if I look at my periodic table, I know that my molar mass for carbon is 12.01. I know that my molar mass for hydrogen is 1.008. And I know that my molar mass for oxygen is 16.00. So when I take those numbers and multiply them, okay? Okay, I'll explain that too. Matter of fact, B-Move, I'm going to explain that right now about what if you're adding. So when you take these numbers right here, you've got your 12 times 12.01, you get 144.12. For hydrogen, you get 22 times 1.008, and you get 22.176. And then for oxygen, you got 11 of those times 16, and that gives you just simply 176.00. So what you're going to do when you add these numbers together, okay? And let me scroll the screen down a little bit so you can see that. When you add all 3 of these numbers together, you go with the least amount of digits after the decimal. So I'm going to highlight these numbers. I only have 2 numbers after the decimal in this particular value. I have 3 significant digits here after the decimal for this number. Over here for this last one, I have 2. So when I add all these numbers up, and I'm going to do that right now so you can see that, 144.12, whoops, plus 22.176 plus 176.00, this gives me 342.296. 342.296. But remember, I only need 2 of those numbers after the decimal. So that 6 tells that 9 to go up. And this becomes 342.296. 342.30. Okay, 342.30 grams per mole. Okay, so your significant digits means that when you are adding and subtracting, you go with the least amount of numbers after the decimal. But when you are multiplying and dividing, you go with the whole number, the least amount based on the whole number. I hope that answered your question. Oh, thank you so much. Thank you. The cherries, thank you. Yes, I know significant digits can be a little irritating at times, and it's because of the way we have to make sure that you stick to it. And here's why. Whenever you're doing significant digits, if you don't keep up with these numbers like this in this manner, when you do your homework online and you're doing your test online, the numbers are pre-programmed according to the correct number of significant digits. So if you just plug all those numbers in and said, my final answer is 342.296, you're going to get that number wrong or that answer wrong. You've got to keep up with those sig figs. The same thing for over here with this number, where we have 0.320 divided by 1.50. So I'm going to plug that back in just to show you all something. 0.320 divided by 1.50. Okay, so you see you have all these numbers, right? If you plug all those numbers in on your test, your teachers are going to mark it wrong, or they may give you partial credit because they're thinking that way. You did not use the correct number of significant digits. You only needed 3 of those numbers, 0.213. But had you put 0.21, because you're thinking that this zeros on the end right here, let me show you what I'm talking about right here. If you're thinking that these zeros don't count and you just plugged in 0.21, and trust and believe there's an answer on your multiple choice questions that'll say 0.21, you'll get it wrong and not realize why. Yes, that's right, Cherries. You got to go from start to finish to remember those significant digits. So what specific do you want to know, B-Move, about the conversions for the metric system? Okay, so show how to answer your question. Molality is basically used to calculate the freezing point for lowering or boiling point for elevation. And so we have to use the abbreviation of the molality because you're dealing with the moles of the solute divided by, of course, your kilograms of your solvent. So a lot of times people seem to think, or students seem to think rather, that we should use molarity, but remember, molarity refers to moles per liter, whereas molality refers to the moles per solvent. And it's not the volume of the solution, but the kilograms of the solvent. Oh, thank you. Thank you, thank you, thank you. You're welcome, Shohag. You're welcome. So, D, have you been taking notes? Like, do you have all of your notes? Have you been doing practice tests, in class? I know a lot of students are anxious to take that AP Chem exam, and they will provide you with certain formulas, like a formula sheet, and of course the periodic table. But has your teacher been giving you all mock tests? You may want to go online to get some free mock tests on the AP Chemistry website. I think it's under the College Board. Good, 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 good. And although I never taught, when I taught high school, I never taught AP, but I mean it's the same thing as general chemistry. Yes, matter of fact, like this is one of the books I use by Barron, and of course they have a different one, a different chemistry book now. I mean, this is several years ago that I actually had this, but Barron is a good source. Um, but pretty much I would recommend that you go onto the College Board to get that. And said I can't get myself to study for the AP exam. Yeah. Yeah, the biggest thing is, yes, is just going onto their website and getting copies of old chemistry exams, old AP exams. And even though they're old, I mean, we're saying like 2 or 3 years old, the information is still relative. Matter of fact, let me see if I can pull up some stuff for you, just to kind of give you an idea of what I'm talking about. Let's see. AP chemistry exams from the College Board. Let me move this out the way. But they do have the exams in terms of what you can expect. And here's the, it says, encourage your students to visit the AP Chemistry student page for exam information. Okay, and they give you all the specifications. So you have 3 hours and 15 minutes to take it. And you are allowed to use a scientific or graphing calculator, and they will provide you a formula sheet, like I mentioned before, and the periodic table. So that's good. And I know a lot of students are looking forward to this big day, May 6th. May 6th. Yep. And then they're telling you what you can expect, for the exam. The AP calculus exam, let me see. Yes, thank you. I go live Monday through Thursday, 12 noon Eastern Standard Time. Oh, fantastic. You are a pre-nursing student. Congratulations. Yes, I go live Monday through Thursday, 12 noon Eastern Standard Time. And a lot of my students that I teach are pre-nursing students. In the AP calculus exam is Monday, May 13th. Let me zoom in so you can see that. Monday, May. You're welcome. And thank you so much. Hey, Yana. Hey, Diana. Hey, Adrian. Yes. And I try to answer all types of questions, that students tend to have. Took a SS. What is that? No, this is not for the TEAS exam. Oh, well, or if you're asking whatever I tutor or teach, yeah, anything that I do in chemistry could be applied to the TEAS exam. Oh, you took a screenshot. Gotcha. Gotcha. Yes, I will be covering electrochemistry tomorrow, Shohag. Yes. Listen, D, I've been trying to get these what you call them? Texting things. Alec, you want to know how to prepare for the IB chemistry? Yes, same thing. I would recommend that you guys go online and just Google IB chemistry exams and you know, take those practice tests, take the practice exams. And I know it is a lot of information. I know. But hopefully, oh, and see, this is 144 pages. Oh, Lord. Let me zoom out so y'all can see that. Let me zoom in so y'all can see that page count. 144. YouTube, I'm logging y'all off.